Hello, welcome to a video on convolution. Just one example that I think is kind of a fun example. We want to get the Dirac delta of t minus 1 convoluted with e to the 2t. So before I do it, let's do a few side things. So let's do some side work. So first off, if I have f of t convoluted with g of t, what's that equal to? Right? That's our integral from 0 to t of f of t minus u times g of u du. So that's our definition of convolution. So now, if I were to make a quick substitution, right? So let's say I say that tau is equal to t minus u. So that means that u is equal to t minus tau, right? And so if we're doing a substitution, not always, but very often, your teacher's going to want you to change your limits of integration. So tau, when what is equal to 0? So we're integrating with respect to u. So when u is equal to 0, is just t. Tau, when u is equal to t, is equal to what? Just 0. And now, I think that's almost it, right? We have to take the derivative here, so d tau is going to be negative du, so negative d tau is equal to du, right? So let's plug all that in. So my integral is now going, instead of 0, it's going to go from t to 0. And my du I'm replacing with negative d tau, right? So negative f of t minus u is just tau. And then g of u is t minus tau d tau. So let's make a quick simplification, right? Remember back in Calculus 1, we know if we have a negative out front here, this is the exact same as 0 to t. And I'm just going to write the g of tau first, g of t minus tau, f of tau d tau. So what is this equal to? It's not a trick, right? We have this. Compare this to this guy. And so this is exactly the same as g of t convoluted with f of t. So we know that their convolution is commutative, right? So that's almost all we need to solve this. There's just one more thing. So if we're going to take the integral from, let's say, negative infinity to infinity of t minus delta of t minus c with g of t dt, what's that equal to? Well, remember that this is defined to be equal to g of c. And the way that's usually, we can derive it, I can probably derive that in another video. Just a quick intuition on how to get started. Remember that the Dirac delta function is equal to the limit as epsilon goes to 0 of f sub epsilon of t, right? And this is equal to 0 when t is unequal to 0, and infinity when t is equal to 0, and that this f sub epsilon of t is itself equal to 0 whenever t is greater than epsilon, and 1 over 2 epsilon whenever t, oops, sorry about that, is less than or equal to epsilon. And the picture that goes along with this is if this is t and f of t, and we're going, have all these colors, I should probably use some of them, right? Negative epsilon to epsilon, and we'll say this is 1 over 2 epsilon. And that's essentially how we're defining this f sub epsilon of t. And the idea is that we can shrink this epsilon, and as we do, this f sub, as we take the limit of that, it's going to go off to infinity, right? As this gets smaller and smaller, as these guys come closer and closer together, it's going to keep going up and going up and going up until once we're at 0, when t is equal to 0, we're at infinity, right? So that's some background, some intuition if you want to go ahead and derive this, but this is typically how we just define our Dirac delta as this integral. As the function, it's not technically a function, but we treat it as a function, that when you take the integral from negative infinity to infinity with a g of t, with another function of t, your result is just g of c, whatever this change is here. And so if it was delta of t with no c here, this would just be g of 0, right? Okay, so now let's rewrite this guy. So this is the same as e to the 2t convoluted with delta of t minus 1. So if you're not sure what to do, always just go back to the definition, right? So our definition, convolution, 0 to t, e, but we need to replace the t with t minus u, right? And then the other function is just g of u. So we're going to have delta of u minus 1 dt. And so what are we going to do now? We can just use our definition, right? Our definition of our Dirac delta function. This is going to be g of c. But in this case, this is our g, right? So this is going to be e to the 2 t minus c. And c is just 1. And so we'd have e to the 2t minus 2. And so it's just a real quick example of kind of a tricky problem. If you try doing it the other way, you'll run into a problem, right? You're going to replace your t with t minus u, and then you're going to have to try to integrate. And I would imagine it might be a little bit more difficult. So hopefully that helped, and I'll see you in the next video.